right, guys, welcome to week one. As we go through these notes, I encourage you to make a copy of this template and fill in notes as I talk through it. And then there'll be lots of practice for you to work through afterwards. So as we see here, our lesson one objectives for week one. Differentiate between states of matter. Tell the difference between states of matter based on particle drawings. And secondly, to analyze matter based on properties and physical versus chemical changes. All right, let's jump in. So what is chemistry? We see here that chemistry is a way of studying matter in terms of composition, which is another way of saying what it is made of. We can study matter in terms of its structure or the arrangement of all the different parts. We can also study chemistry based on the properties or the behavior of the matter. And then lastly, we can look at matter in terms of how it changes, how it transforms. And this is usually influenced by energy. These changes that we see in matter, influenced by energy. Why is chemistry important? Well, as we'll find out, everyone and everything in the world involves chemistry. It's very important to us. Chemistry is the study of matter, and it mentions these things that we talked about earlier: composition, or what it's made of; properties, remembers how it behaves; and then changes or transformations influenced by energy. Matter is anything that has mass and takes up space or takes up any kind of volume. So that's the basic definition of matter. We can next look at the different states of matter. So I'm sure you're familiar with the different states of matter. On the side here we see a drawing. This is what's called a particle drawing. This one's a little difficult to see. This is actually water molecules, and this is drawn in a solid state. And so what are some things that we can say about a solid state? First, it has a definite volume. A definite volume. It maintains its shape regardless of what container it is in. Maintains its shape, so some say it has a definite shape. And then lastly, the particles lie close together. In a regular pattern. Lie close together in a regular pattern. So if you kind of zoom in on this picture on the handout, you can see that these are very close together, and this is what a particle drawing of a solid would look like. Next we have the liquid state, and this is again water, and hopefully you can see that the particles are a bit looser, if you will, not as close together. Liquid still has a definite volume. However, it takes the shape of its container. So you're quite familiar with water, and you can pour water into different shaped containers, and it takes on the shape of the container. Liquid particles are still close together, but they do have the ability to move past one another. The molecules themselves can move past one another. And so again, this is a particle drawing of what liquid state of matter would look like. The third state of matter that we see is the gas state. And again, we have a particle drawing of water in a gas state. We typically call this water vapor, but it's just water in the gas state. Gas has no definite shape. It assumes the shape of whatever container that it's in, and it has no definite volume. again, it takes the volume of the container that it's in. Gas particles are very far apart. Oh, I left out the word far. Very far apart. And they move around randomly. So gas particles are very far apart, as you can see in the picture, and they move around randomly. When we study gases, we'll see that they actually move in straight lines. Gas particles move in straight lines until they hit something. They can either hit another gas particle, and then they would change directions and go the other way, or they might even hit the side of the container itself. All right, in the next section, we'll look at the behavior of matter. And so we can talk about that in terms of either physical or chemical properties. So let's start with physical properties. So matter can take on physical properties, and these are things that can be observed or measured without changing the composition. Remember, composition, that word means what it's made of, the material that it's made of. And so some examples of physical property, you can list them here. One is boiling point. Boiling point. Another would be melting point. These are actually the temperature at which boiling and melting takes place. And that's different for different substances. We can also talk about something called solubility. Solubility is describing how something will dissolve in a solvent. Typically the solvent is water, so there are a lot of things that are soluble in water. Another is color. This is also a physical property. Another is odor. And lastly, just the state of matter, whether it's a solid, a liquid, or a gas. State of matter. So those are all considered physical properties. Next, we can talk about a physical change. So this is slightly different, physical change. It says a physical change alters the material without changing its composition. So again, remember what the word composition means. We can alter the material without changing what it's made of. So things like tearing a piece of paper, that would alter the material, but it didn't change what the paper was made of. There's lots of things we could list here for physical changes. Physical changes are going to be covered in more detail in Chapter 7. The picture that you see here, again, it has a particle drawing of water, and it's showing that changing from one state of matter to another is considered a physical change. So here we have solid water, think of ice, and it is undergoing melting, which changes it into liquid water, and that is a physical change. And then we can continue to apply heat, and boiling would take place, and that would change it into water vapor. So these are all examples of a physical change. Next, we want to briefly just look at chemical properties. A chemical property determines how a substance can be converted into another substance. And then we have chemical change. And this is actually the reaction that converts one substance into another. And we'll spend a lot of time talking about that in later chapters. This picture that you see here is oxygen gas and hydrogen gas. They're put together and they are chemically combined. A chemical reaction takes place and it turns into water. And so that's an example of a chemical change. All right, the next section we want to talk about how we can classify matter. And so all matter can either be classified as a pure substance or as a mixture. So these are two very broad categories for matter, a pure substance and a mixture. So first of all, a pure substance. Pure substance is composed of only composed of only a single component. That makes more sense. A single component. So composed only one thing, basically. A pure substance composed of only a single component. That could be a single type of atom or a single molecule. These would be considered pure substances. It has a constant composition, So an example of a pure substance would be water. And water is always made of 2 hydrogens and 1 oxygen. So H2O is the formula, the chemical formula for water. And it doesn't matter how much water you have, whether it is a glass of water or a pond full of water. Water still has a constant composition. It's made of hydrogen, 2 hydrogens, and 1 oxygen. And then lastly, it cannot be broken down into other pure substances by physical changes. So you can't just melt it and it turn into, like if we take water and we melt water, it's not going to turn into hydrogen and oxygen. It's still water. And so that's a physical change. And so we know that because water cannot be broken down into its parts through physical means, then it is a pure substance. So we can further classify pure substances into 2 other categories. So a pure substance is classified as either an element or a compound. An element or a compound. So an element is a pure substance that cannot be broken down by chemical change. So we have the periodic table of elements. There's 118 elements on the periodic table, and these are all considered pure substances, and most of them typically stand on their own. They don't have to be combined with other things. Another pure substance is a compound, and so a compound is a pure substance that is formed from 2 or more elements being chemically joined together. And so chemically joining 2 or more elements together makes a compound. The pictures that you see here are examples of elements and compounds. And so the first picture, this is aluminum foil, and it's simply made of aluminum atoms. And so that would be an example of elements that make up this pure substance, aluminum foil. The second thing you see here, it looks like some compressed nitrogen, pressurized nitrogen, and so inside this container is pure nitrogen, and so that would be considered pure substance. In the glass, you see a glass of water, and in the particle drawing, you see the different parts, and there's hydrogen and oxygen that have been chemically combined together to make water, and so that's a pure substance in the form of a compound. And lastly, we have table salt, and so this is sodium and chlorine that have been chemically combined to make a compound that we call sodium chloride, and that is a pure substance. All right, let's talk about the other category, which is mixtures. Mixture is the other classification of matter. Excuse me, mixture composed of more than one component. Pure substance only was composed of one component. Mixtures are more than one component. They can have varying composition. Varying composition can be any combination of solid, liquid, gas. Might think of Kool-Aid. That's a good example. Everybody knows about Kool-Aid, and everybody fixes their Kool-Aid a little differently. Some like it really sweet, and some like it not so sweet. And so that's what we mean by varying composition. Kool-Aid is simply water and sugar, mainly, with a little bit of flavoring. So some people like more sugar than others, and so that would be an example of a mixture. Mixtures can be separated into their components by a physical process. So a physical process like evaporation is a common way that mixtures are separated. The picture that it's showing you here is sugar that's been dissolved in water, and we can simply evaporate the water and the sugar will be left behind in the bottom of the cup. All right, so that's a brief overview of matter. And the last slide that we see here is a graphic organizer that's kind of putting all of this classification together. So what I'd like for you to do is to stop the video and see if you can fill in these blanks. Maybe look back at the notes and try to fill in these blanks, and then you can start the video and check your work. So go ahead and pause the video. All right, now let's see how good a job you did. So the main topic here, of course, is matter. So matter goes in the top box. And then it asks you a question, and whether you answer yes or no to the question will lead you to the different terms. So matter that can be separated by physical process, if you answered yes to that, then that would be a mixture. Mixtures can be separated by physical process. We talked about evaporation, a way to separate sugar from the water. If the answer was no, it cannot be separated by a physical process, then that is a pure substance. A pure substance. Okay, and as we saw earlier, there are two types of pure substances. There were elements and compounds. And so again, you have a question. It says, can it be broken down into simpler substances by a chemical reaction? The answer is no, it cannot be broken down even by a chemical process. Then that answer is an element. And we talked about, we have all of the elements on the periodic table that we'll become quite familiar with over this semester. And then if we answer yes to this question, it can be broken down into simpler substances by chemical reaction, then that answer is a compound. All right, that concludes our week 1 notes. I encourage you to practice what we've talked about. There's lots of practice on the computer that will take you through different modules over these different topics. I will see you next week.